But before we start, let me just introduce myself. I'm Dominik. I'm a Flutter GDE. I really enjoy giving public speeches about Flutter. I'm also freelancing. Right now, I'm working for a company called Visible, and we're building a platform for people that struggle with chronic illnesses, especially with long COVID, which in recent years has become a really serious trouble for many people, especially in UK. I think it's very present. And besides that, I'm trying to more or less occasionally write on my blog or on my Twitter. So if you look for some Flutter content, I kindly invite you to just subscribe to my blog and my Twitter if you're into that. And so today we're going to talk about platform views, and some of the folks that I talked to have never used them before. So I have a question to you also to kind of warm us up a little bit. Has anybody, and please answer with like a single clap. Has anybody here used platform views in Flutter before? All right, so a couple of people. So that's nice. We need to practice on the tempo probably a little bit, but like it was cool. But maybe, do you know, maybe somebody here knows that they will use platform views in the future, maybe next year or maybe in the next project? Yeah, so a couple people, cool. So maybe for you it will be interesting. So the major question with platform views, I'm gonna talk about this in a second, is like sometimes you may want to use some library. And this is especially applicable for things like photo editors or video editors, or maybe in our case, we had to use a heart rate sensor that uses the camera as a preview. Or things like, for instance, on iPad, you had this feature of scribbling into the text field. And for a couple months, actually, it was not possible to do in Flutter. So the only way to have like the scribble support was to use a platform view. So there are many cases, even like a very ordinary apps, where you have to use platform views. And Flutter provides this nice way to render almost any native view inside of Flutter. There's a couple of different considerations, and we're going to talk about them today. But to make this a little bit more entertaining, I wanted to give myself some challenge, some goal. And like for many years now, I've been trying to do this on my own or with some colleagues. And the main goal for me while preparing this presentation was to create something that I would enjoy, and maybe it would be also cool to show publicly, and it was to build my own camera. So I don't know how many of you have used camera in Flutter before, but it's not like the highest quality. It's not the best camera implementation that you can have in a mobile app. And many teams struggle when they have to use the official camera or some of the libraries that are out there. And the conclusion that I came to a couple months ago was that actually it's easier to write the camera view natively in Swift and in Kotlin, and then embed this in the Flutter application, than to try to come up or modify the existing camera for your needs. So things like high frame rate or pro level controls of the camera, maybe using different lenses and things like that. So my goal, and I'm gonna kind of go with you today through this journey, is to build our own camera implementation in Flutter using platform views. But so if you ever looked for, there is a couple of different approaches. Like, so the official camera. 2 years ago, together with my friend Razvan, we tried to port React Native camera to Flutter with little success. And today we're going to try something different. So there's also a couple of cool other libraries that I can recommend, but we're going to try something on our own. Before we dive into the technical details, how to display the camera view, we just have to do some theory 101 into platform views. So how platform views, which are the native views from Android or iOS, are displayed in Flutter. So we can start with like a simplified common flow for both iOS and Android. And once you kind of understand this, then you will see all the similarities between all the different platforms. So as always in Flutter, we start with some widget. So we have a widget somewhere in our widget tree that's the thing that we define, we control, that's specific to our domain. And then Flutter provides us with some platform-specific widget that will render a native view that we will create on the native side. So this comes from the widgets library and is different for iOS and Android. We're going to go into that in a second. Then there is a native side. So the right-hand side of this diagram shows our native realm, I would say. So there's, whenever you use plugins, and I think there's another talk about plugins today in the afternoon. So if you would like to learn more about plugins, I can highly recommend that. But when you, if you think about the platform view, it's essentially a type of plugin, Flutter plugin. And every time you use a plugin in Flutter, you have to register it. So there is always some registry on the native side where you have to register, as the name implies, thing that you will use on the native, in the native code. So what you will register is a view factory. So this is just a class that knows how, what kind of view and how it should be created. So this view factory, there's different implementations for platforms, but this view factory needs to provide us with a platform view implementation that's also provided by the Flutter. And then the last part, the Flutter platform view will again create something that we will have control over. This will be the thing that we define, and this is a native view specific for a given platform. So with this simple flow, like a couple of pieces that we have to arrange, we should be ready to implement this. So let's start with iOS. So iOS is pretty simple. There is not much, like the flow overlaps what we have seen on a previous slide. There's a couple of different names of classes. Like for instance, on iOS, there's a common registry for plugins and platform views, which is just called Flutter Plugin Registrar. And then there's a couple of interfaces like Flutter and Platform View Factory. But once you see the code, you will see that it's actually very simple. There's not much happening besides some boilerplate code. And what is important on iOS, we can return any UI view. But we're gonna dive into like what kind of UI view we can return in iOS in a second. And on the Flutter side, the widget that's used to render a native view is just called UIKit view. On Android, the situation is a bit more complex. As usual, we have different versions of Android. We have different vendors and makes and things like that. So, and also it's a bit more advanced. You have access to a little bit lower level if you implement Android native view. The right-hand side, the native side, is very similar to what we saw just a second ago. The main difference is that on Android, there is a separate registry for platform views. So on iOS, there was a single registry. Here we have two registries, one for plugins and the other for platform views. And we can just return any view. The major difference is that besides having just a simple Android view on the Flutter side, we also have a way to render our native view with a bit more control through a widget called Platform View Link that needs to return Android view surface. And this is where we kind of dive deeper into the Android flow and like what kind of differences are there. So until like a few months ago, before Flutter 3, there were two ways to render platform views on Android. One of them was called Virtual Display, which is like the simple one. So if you use just the Android view, this is like just showing like a rasterized preview of a native view inside of Flutter with no accessibility support. If you would open the layout inspector in Android Studio with a Flutter application showing the visual display view, you wouldn't see it. However, there was also another more expensive way to show native view, which is called hybrid composition. And this would mean that the native view is interlaced into the widget tree, and it has accessibility support. It's visible by the accessibility tools, by the layout inspector, and things like that. However, this year with Flutter 3 and actually Flutter 3.3, a new way of rendering native views on Android has been added, which has a really fancy name, texture layer hybrid composition. And this mode actually is aimed to be even more powerful or like more comprehensive. it's going to replace probably the virtual display mode. But at the time, especially because Flutter needs to support a wide range of different Android versions, there is some logic and confusion, maybe even when it comes to which mode you should use and when. Like if you have a very simple view, the virtual display should be fine, and over time it's going to be using the TLHC anyway. Whereas like if you have some more complex views, like for instance we had this case with the camera, we are using this more expensive texture layer hybrid composition, or hybrid composition. And the logic actually changes. Like there's commits getting added to Flutter as we speak, like this week or last week. There were changes and fixes, because unfortunately this refactor has introduced a lot of bugs and breaking changes. And for instance, if you ever used platform view this year, then you probably encountered issues with platform views not rendering correctly in Flutter 3. So hopefully, with some of the other changes that I'm going to talk about in a second, we will have some more stable situation with platform views. So this is the difference that I was talking about. So if you open the virtual display in Android in Layout Inspector, you don't see anything. Whereas with hybrid composition, you see the whole layout structure, all the elements in the view or the components in the view are visible. You can even inspect the fonts and things like that. Same with iOS. On iOS, you only have one way to render the platform view, which is hybrid composition. So the native view is actually like composed, interlaced into the widget tree, and it's visible, for instance, to the Xcode layout inspector and to the accessibility tools and things like that. Pretty powerful, and it works out of the box. So let's go back to our goal. Like we wanted to show our camera, right? So one thing that's like helped me to go through this challenge a little bit quicker was to just try to leverage some existing pretty powerful libraries. So again, the problem with Flutter is that it tries to have a common API for Android and iOS, and it means that there's like some features are not available or not implemented just yet, or it means that you cannot expose some things without providing the support, for instance, for web, right? Once camera plugin supports web, all the things need to go in line. And for now, we just want to capture the photo. That's my goal for today. And the thing that I also want to have and to explore a little bit was to use a plugin or federated plugin architecture, so that if I ever publish this camera library, that's a big word for this, but like camera library, then I hope that maybe somebody, if they want, they can provide implementation for a different platform. So let's start with actual code. It's not going to be a lot of code. This is all simple, and actually the docs for that are pretty good. But let's start with the iOS side of the Dart side of the iOS implementation. So as you remember, we had this UI kit view, and like besides the boilerplate, the only important part here is just the ID that we will reference on the native side when we will implement our UI kit view. On the Swift side, we have our plugin registry, and that's, again, a bit of boilerplate, and we just need to refer to the same key as we used on the Dart side. And then we have this native view factory. You remember the part on the right side where we just tell Flutter in what way how our view needs to be rendered, and we have our FL native view. And here's where the interesting part is gonna happen. So just to spice things a little bit, I wanted to use not just ordinary UI kit view, but I actually wanted to try to embed Swift UI code into the native view and then render it in Flutter. So it's like a inception of having declarative Swift UI code inside of the declarative Flutter code. And I thought it was cool just to try out if it's possible to have a Swift UI. So again, just to kind of see if we have any iOS developers or maybe explorers of Swift UI. Have you ever tried the Swift UI? And this is a like moment for clap. Yeah, a couple of folks actually tried Swift UI. Cool. All right, so if you don't know Swift UI, it's like Flutter, but in Swift, right? So it's pretty cool. And when you read the code, you actually understand it right away. They have, or like SwiftUI has a couple of different keywords than Flutter or Jetpack Compose, but in practice, it's all becoming to like be very similar on all fronts. So we have a VStack, which is a name for a column, and then you have texts, and the major difference is that when you want to style something, you have these modifiers that you add after the component, like font, and the style is a headline. And yeah, if you haven't tried SwiftUI yet, even though it's a Flutter track, try it out. I think you will like it, especially knowing how easy it is to write widget code in Flutter. So this is our SwiftUI view for now. Very simple, nothing fancy. But the cool thing is that here on this preview side, I used something that's called UA hosting controller. And this is a class that allows us to host SwiftUI view inside of the UI kit view. So this is the trick that allowed us to actually fake or like embed the SwiftUI view into our app. And this is the result, right? The code works, and I just added some animations to make it more fancy. But like it works. It's like 60 FPS or like the maximum FPS that your device supports. Super smooth. The quality is like if you would use the normal view. And you will see this in a second, but I tried this with all the different components, and actually it's so smooth. Like sometimes it feels more smooth than the Flutter itself, because like it's actually just the native view. Like the feedback when you scroll things, it's pretty cool. The Android side, pretty simple as well. So we start with the simpler approach, right? What we call the virtual display. And if you want to use the virtual display, you just use this widget, Android view. And similar to iOS side, we just need to know the key. However, if you want to use the hybrid composition, there is a bit more boilerplate. So the point is that you can go to much lower level and have much more granular control over how your native view is displayed. So for instance, you have things like, besides just the type, you have to provide the surface that Android is gonna render, and you can provide things like gesture recognizers. There's a thing called controller, Android view controller. You can tell whether the gesture should be captured by the view or not. Maybe you have some custom UI that you want to put on top of the native view, so you don't want the native view to take your gestures instead. So there's a lot of customization available, and it's a little boilerplate. And the important part is that here we have this init expensive Android view, and like again, the name implies that this is expensive to render, and like it might be expensive on some older Android versions, like before Android 8. And in my tests, I haven't found any performance issues when using that. Of course, and this was using a camera preview, right? And it was just fine. However, if you would use like the other method that's available here, init Android view, it would just be the same as if you would use just a virtual display. I highly recommend you just whenever you do any kind of like low-level Flutter implementation, I recommend just to control and click any of these methods, because like the implementation is older, it's all open source, and you can just see the logic that they use. And like this is how I realized that like the Android view widget is just a wrapper around this, but with the init Android view and things like that. The Kotlin code here, very similar to the Swift code that we've seen before. The important part is here at the bottom, where we just register our platform view this time in the platform view registry, right? So Android is a bit more developed here. Then the native view factory, which is again implementing the platform view factory interface, just needs to know what kind of view needs to be returned. And here I'm just calling it native view, and I'm passing the camera controller that will use methods exposed by the method channel, like take picture. And our native view here is super simple. Again, just a hello from Android label at the center. And I tried to use like XML layouts for that. I didn't succeed, so probably it's possible, but here I just had to like manually create the text view, provide the label and size. For Android developers, probably it's like a very bad code, but I have not done any native Android in years, so so just please forgive me this. And so we know how to display a very simple Android view. And again, it takes like 20 minutes to arrive to this result. So if you ever need to, it's pretty simple, and the result is there very quickly. So how to show the camera view? Like, it will be a bit more complex thing to do, but hopefully it's gonna be as easy as showing the label. So what we will do is that we will just embed like a full camera app. So like, you can build your camera app just in Swift or in Android, and then you can just embed it into the app. And probably it may work with many different solutions. Let's say you have your app and you want to see how would it integrate with Flutter. So you can two ways. You can embed Flutter inside of the native app, but you can also embed native app inside of Flutter. So there are like two ways. Of course, there are trade-offs. It's not like it's not interchangeable. But like, if you have just a single screen, maybe it's like actually a good way, or like a single component. And we will expose some methods for the method channel so that we will be able to control and take picture and switch the camera from the Flutter side. And we will use a sample app that uses Swift UI camera view. This is from Ray Wenderlich, and this is an amazing tutorial even like about Swift UI in general. So if you'd like to follow this, this is the article. And this will be another like sidebar from what we discussed before, but if you ever had to do any plugin code in Flutter on iOS, there's this, for me it's pretty hilarious, like if you like to be able to edit the Swift code with syntax support and autocomplete and things like that, there is one way to do it where you have to open the example app for the plugin. And then if you want to get to your plugin code, there's like this ladder of doom, or like things like that. You have to go to your pods, and then while you go through that, you have to like go through several nested files. Actually, it's like double dots, which means you go up and then you go down. So it's pretty, for me, always when I have to open that, I just find it super funny. And then you just have your access to your Swift code, and you can use Xcode to modify this. I'm telling this because I found that many people, like when they try to even debug plugin code in Flutter, they find it very confusing, and for me it also was not obvious how to do it when I started. So you have the way, and if you run the app from Xcode, you will be able to put breakpoints, to use like the Xcode layout debugging utilities, performance monitoring, and things like that. So this is super powerful, and I think this is one of the strengths of Flutter right now, that you can actually see the native code, debug this easily with the tools that are designed to do so. Yeah, so here are our views that we will show, and yeah, this is what I was talking about. And the view that we're gonna see here is also like, if you like after this one-on-one to Swift UI syntax, you see that we just have a Z stack, which in Flutter is also a stack, like just things on top of each other. And we have just a frame view, which will render our camera preview. We have error view if anything goes wrong, and we have our control view, which is a couple of buttons. And this is the effect, right? Like just embedding this, and like the sample had some effects, so I'm just kind of fooling around here with this. And you remember our label, hello from Swift UI within Flutter, and then we have our camera. This is a GIF, but like in fact it was so smooth compared to, for instance, official camera plugin. I was astonished. Like, if you are able to open just the camera preview and have like 100% frame rate the same way as you have in the official camera, like the iOS camera application, but for me it feels revolutionary having this kind of fidelity and smoothness still in Flutter. Yeah, ultra smooth, and the code for that is super simple as well. So let's go back to the Android, how to show the camera on Android. There's many libraries, and probably some of the Android developers could recommend me something better. But I used a library called Camera View, and like this is used by some chat application in Asia. but it's pretty solid, and it still uses Camera 2 APIs, not Camera X. So Camera X is like this new API for camera that aims to unify handling of different hardware and different Android versions with camera, whereas the Camera 2 is much lower level. And but however, the maintainers of the camera view have solved a lot of these issues. But definitely, if you can just use the Camera X preview as well. That's my goal for the maybe next incarnation of this talk, that maybe we'll be able to run the Camera X camera. And we'll just have a simple camera controller to control our camera view, take pictures, rotate the, like switch the camera and things like that. So the platform view here, and again, I'm doing this in code, but you can potentially you could do this in the XML as well. And what happens here is that I'm just creating this camera view, and I'm layouting this, or like putting this into the frame layout to match the size. It has a lot of nice features like gestures handling. So you remember I told you at the beginning that you can define how gestures are getting handled by the native view. So in this particular case, we want the gestures to be passed to the native view so that they are getting, like for instance, if you have a pinch to zoom or tap to focus, things like that, they are getting handled as they are supposed to. And this is the Android view. And here I added a little bit more UI, right? So we have, like, I don't know if anybody used like old iOS versions, but like I just wanted to kind of have this similar vibes as we like in the old iOS, like a gradient, like neumorphic design, and it works. Like it works super smoothly. Same feeling as on the iOS side. The camera preview just uses as like is as smooth as the native camera preview that you would use in your camera app. Cool stuff, works just fine, and also the performance of that. Whereas like with the official camera plugin, like once you take the picture, like there is a bit of back and forth on the meta channels. Here it's all native within Flutter, so it's super smooth. You can do, like you get the reference to the file very quickly, and it all works just fine. So this is like all kind of casual. There is nothing revolutionary in the things that I've shown when it comes to iOS and Android. However, there is one thing that I was super excited to try out, and I just wanted to see if I can expand this implementation to my desktop, to my Mac. And this is where it gets, I would say, experimental, because there's no official support for platform views in Flutter, and there will be not like for a couple months more. But if you just switch to the master channel of Flutter, so for those that don't know, in Flutter, you have just the stable channel, and there is also beta and master channel. So master channel is like the leading edge, the cutting edge of what's being done with Flutter. And if you switch to that, there is some initial support for the platform views, for now only on Mac, so you cannot do this on Windows. So like what's cool about this, because we use Swift UI, and Swift UI is supported on Mac. We can use exactly the same code. We have some small adjustments, but you can just copy and paste practically the code from the iOS part to Mac part and just have the app running. And this was like a month ago when we tried this for like one of the first times, and like it works just fine. Like you can have a Mac application using the same platform view implementation, the same Swift UI code with just a slight adjustment, but it actually works just fine. You have the same effects, you have the same UI, and like it was like the fact that it took like 10 minutes to like port from iOS to Mac, because again, I'm not trying to like say that Swift UI is better than Flutter, but like it's super cool to be able to run the same code, share it across platforms, and the same, like we have like a double layer shared code where like Flutter is shared and Swift UI is shared, and you only need like KMM library here probably, right, to maybe do some ML or whatever to make it like a filled with all the possible options for sharing code. It works just fine on Mac. However, like of course it's not perfect. It cannot be perfect. It's still initial version. There's a couple of things that don't work properly. So for instance, it's unfortunately in last month, from my previous trial, there are almost the same problems as a few weeks ago. So for instance, it's not fully supported, of course. So for instance, there's no gestures. So if you'd like, you don't have touch screen on Macs, but you have mouse, right? So a mouse is also a type of gesture. It doesn't work if you have any kind of, if you want to pass gestures from Flutter to Mac, it doesn't work. But like I had these buttons, and these buttons can just, they operate natively, right? So they don't need Flutter to pass the gesture to them. It's if you have a button that works like that, exposed on the native side, the button will work as it's supposed to work. It's just if you would have like maybe you would like a interactive viewer or maybe list view that passes some gesture to the platform view, then it's not going to work. But like in general, like it's just fine. The window is not able to resize. That's a bit of a problem. So you cannot resize a window if you show a platform view on Mac. That's a threading issue because when you start, I don't understand this entirely, but like whenever you resize the window, the view needs to re-render, right? And there is some kind of threading issue that they try to fight with each other. There is a fix for that already, and actually, last month when I done this talk for the last time, I had a chat with a person from a company called Superlist, and they provided a fix for that within 20 minutes. So there is a custom version for that of Flutter engine that solves that, but it's not been merged into Flutter just yet. And the other issue is that on macOS, the platform view is always shown above everything. So if you'd like to put any custom UI right now on top of the widget, it will not work. It's just hovering over everything. And because in general, desktop support on Mac in Flutter is still like a beta version, there is a different framework on iOS to use. So the API is slightly different. So this is the adjustment that I had to do, but like it's nothing critical. It doesn't block you from working with that. Yeah, so as I said, the setup is almost exactly the same on iOS. You do this through the Xcode. You can debug, you can see the layout and things like that. Yeah, so just to wrap up some things, I know it was a bit of theoretical, and but like you can actually get the sample and run it. And if you want to see kind of where we are or where Flutter is in terms of support for that, there's a couple of projects in GitHub repository where you can follow that. So for instance, the platform views for macOS is supposed to be ready, like more or less right now. They are not, so hopefully they will be ready sometime soon. And the same for, and the same comes to Windows. Like there is some initial support for platform views on Windows. Some folks manage to run WebView or video player like that, but it's still very flaky. Let's just quickly talk about scrolling, because I think this is important. And if you ever have like a UI where you have a lot of, let's say, platform views that need to be in a scrollable environment, that gets tricky. Like, so for instance, here are some platform views that are inside of the scroll container. You can imagine ads, videos, or maybe some custom controls that need to be scrolled. So this works, but has some performance issues. So again, if you think about this kind of use case where you have ads or something similar, it gets tricky, and this is one of the reasons why Google Ads has some troubles. So for instance, if you look at this, actually the platform view gets rendered even before it appears on the screen. So with ads, you have the problem of attribution, right? Because the ad gets rendered before it actually enters the screen. So it's a tricky problem because ad network can ban you if you falsely claim that the ad was seen, which is not true. So we have to work around this as well. Yeah, so this is a bit junky still, but it works just fine. And when I tried to just have a couple of cameras in a scroll view, it was rubbish. Like it didn't work properly. But like at least it renders. So if you have a static content, it should be fine. But like with a bit more probably you could also optimize this to not create 4 views, just use one and show it 4 times. Yeah, so there's some common issues, and if you start dig deeper, we could spend another 20 minutes just going through that. It's no point. There's no point, but like there's a lot of issues still. But if you are going to build, and a couple of people actually claim that they're going to use platform views next year, and maybe there's like a fraction of people that also use desktop, that's the moment where you have to kind of try get on board and see if you can use platform views. And I know, for instance, some companies already do pretty amazing job with video players on desktop with Flutter. There's one company in Sweden that's gonna do video calling in Flutter. So cool things are happening, and like we are at the stage where it all gets kind of together. And like 3 years ago at Flutter Europe, we just kind of entered the age where desktop, Flutter for desktop started. And here we are 3 years later. Desktop is pretty stable, couple of things left, and one of them is platform use. The other is probably multi-window support. But we are getting there, and it's super exciting to see this progress that happened over the last 3 years. And I hope that like if we meet next year, we'll be having even more cool things to share. So if you want, you can try out the sample application. I tested this today in the morning. It still works. If you have any issues, just let me know. If you go to this website, you will get the sample code, the presentation, and an article that is like a written version of today's talk. So here's a QR code. If you want to like get the source code, try it out for yourself, I kindly invite you. And I think that will be all for today. If you have any questions, we just have 2 minutes left, so I'd rather have them like maybe on the side. Thank you very much. It was a pleasure to talk to you, and I hope you enjoyed. Thank you very much.